Hey everyone, my name is Vanessa. I'm a DevRel at Dabl.Club. Today, I'm going to walk you through how to build a full stack application on Polygon zkEVM. Before we start building, I would like to answer 3 fundamental questions. What is an L2? Why do we need them? And how do they work? In L2, it derives its security from the data availability from the L1. You can see this image behind me. There's a lot going on, so let me explain what you're looking at. In that pink rectangle is our L1 Ethereum. In the green boxes, we have our L2s, both optimistic and zk rollups. And then over to the right, we have our sidechains. Now, we're not going to really talk about sidechains in this workshop, but what you want to know is that L2s differ from sidechains in that L2s inherit their security from the L1, from Ethereum. That means that L2s use the consensus that Ethereum has, and they don't have to create their own. This is why you may hear the argument that L2s are more secure than a sidechain, because sidechains, you're essentially having to trust their own data integrity. And Ethereum is one of the most used blockchains. And so because of its decentralization and security, this is why we have a lot of trust in Ethereum, probably more trust in Ethereum than we do with centralized banks. What you'll want to remember is that L2s inherit the L1 security by using the consensus model from Ethereum. Transactions get posted back to Ethereum. Optimistic rollups use fraud proofs that are also included when they post back to Ethereum. And then zk rollups use validity proofs that are used in order to be able to post back to Ethereum. This is what an L2 is on a high level. By answering the next 2 questions, we're going to understand what an L2 is even more. The next question was, why do we need them? Well, you've probably heard of the blockchain trilemma problem, and that is that no blockchain can have all 3: scalability, security, and decentralization. Well, our favorite blockchain, Ethereum, is right in between security and decentralization because that's what it does really, really well. You may have remembered back in 2021 in the bull market when gas fees were extremely high. I still remember trying to mint a developer DAO NFT, and the gas fees were like over $100. It just made it extremely inaccessible for a lot of people. And even after the merge, when the consensus went from proof of work to proof of stake, it was still expensive and kind of goes against the whole ethos of Web3 and blockchain that you want it to be accessible to everyone in the world. So if you want to make it accessible to everyone in the world, it can't be cost prohibitive. L2s are helping scale Ethereum by processing the transactions off chain. Let's jump a little bit into how they work. These are the 4 steps of a typical blockchain. The first step is that the transaction gets executed. The transaction needs to be processed. The transaction needs to be verified. And lastly, the transaction needs to be published on chain. L2s take care of step 2. They process the transactions off chain. All right, now that we've covered on a high level what L2s are, how they work, and why we need them, let's go into building. We go into docs.polygontechnology.tools. We'll go into the developer tools and we can check out the dApp Launchpad from here. So let's go ahead and click on that. We'll click on the quick start. And if you don't already have if you haven't already installed dApp Launchpad, you can do so by entering this command. I already have it installed, so I'm going to just run dApp Launchpad init for initialization, and we're going to call this demo workshop. Awesome. Let's go ahead and get that opened. All right. From here, you can see we've got 2 directories. We have our front end and our smart contracts. So why don't we take a look at our smart contract, what we've got. We've got this wall contract. We've got a struct, the properties that the message will have. It'll have a string address and a uint256, which will include the message, sender, and the timestamp. We have an event that will be triggered, and we can listen to this on the front end part of the application. We have this array of message, which will be storing all the messages. And then we have two functions. We have this post message as well as this get all posted messages. Pretty straightforward. Now we can go to our front end and we can take a look at this example file. So I'm going to just copy this, and we can do that by running cp for copy. And we're going to let the file know what we're trying to actually copy. We have to go into our front end first. Duh. All right, so let's do that again. And now we see this .env file came up. So let's go back to Wallet Connect. We can copy this ID and we'll go back to our file here. We'll paste that in here. And let's see, next step, let's go into our smart contracts. Anytime you're deploying, you're going to need a private key. I'll come over to MetaMask. And I like using this burner account. Don't want you all to see my private keys, but it's fine. Because if you drain me, I'll just get more fake ETH. It's fine. Now we want to go into our smart contracts and basically do the same thing we just did. But now let's cd into the smart contract directory. And we'll run that command again because it's the same file name. Now let's go ahead and get this running. Now, if we go to our quick start, we have a couple of different commands that we can run. So this command will get us launched on local. So let's go ahead and do that. As you can see, Hardhat is running in the background. So we have this like remote server. All right. Now that we've got that running, let's go ahead and import one of these private keys. So we can go into MetaMask and I'm going to just import an account. We'll do that. We can refresh this and we're going to try account 3. So we're going to confirm. Looks good to me. Looks like we're connected on Hardhat. All right, so hello from localhost. It's asking us to post this message. And there we go. We have hello from localhost. So we can make edits to this pretty quickly, and we can actually just find where this also is. So your local server is running. Let's check out where this is at. So let's take a look at what we have on our front end. So, all right. So now that we've done this from localhost, we can now check out what the next steps would be if we want to deploy this actually on our Polygon zkEVM. Now, before we do that, we can take a look at Hardhat config, and we'll just remove everything that is not Polygon zkEVM just to clean it up a bit. So let's even remove Ethereum. We're not going to be doing that. And this does need to be updated. This is actually linking to our old testnet. So we can find the information we need on chainlist. So this is the new chain ID is 2442. And I'm going to just copy this RPC server address. Let me go back to the URL. I'll paste this in here. And let's just remove that. Cool. All right, so let's just turn the local server off. I'll go back to the quick start. And next, what we want to do is we want to deploy this to production. We'll copy that command, which is dApp launchpad deploy -n for network. And we can just paste Polygon zkEVM testnet. So we will paste that in, and you just want to accept everything that you'll see there. So let's wait for that to happen. Set up and deploy. We're going to say yes, yes, projects linked to it. Yes. So we'll check it out. All right, this does take a little bit. So once it's fully done, let's check out what we have in our production. We can just copy this link over, head to our browser. All right, so let's try connecting our wallet. We're going to use MetaMask. And this time we're going to use our burner because we're on the Polygon zk testnet. Let's say hello from zkEVM testnet. Well, let's go ahead and confirm. And once we do that, we can give it a sec, and there we go. Hello from zkEVM testnet. We can also check out Polygon scan. And let's check Polygon scan, and we'll make sure we choose Cardona testnet. And let's just check out the burner address that I just made a transaction on. So here we go. We did a couple of transactions here. This is the contract creation that we made 4 minutes ago. So let's click on this. And then, yeah, these are our transactions. And just like that, in a couple of easy steps, you can deploy a full stack application on Polygon zkEVM. Thanks so much for watching, everyone. Have a great day.